Right, the next reaction I want to talk about is ester formation. Now an ester is a combination of a carboxylic acid and an alcohol. Now if you look at the functionalities that we're using here, we've got the carboxylic acid here that's C double bond O with the OH reacting with the alcohol to give our ester functionality. Now remember, what defines the next ester functionality is the replacement of the OH with an OC. Now what's important though is to look at the pattern and to know where these different atoms came from. The C double bond O part obviously comes from this part, from the carboxylic acid, and this part connected to the C double bond O, all of this here actually comes from the alcohol. We lose this OH and this hydrogen as H2O, so we're actually getting water as a side product here. Now if we look at the actual pattern for the reaction, what we're looking at is the O from the alcohol, there we go, this O here, joining on to the C double bond O and losing the OH and the H. Now what I'm showing here is not a mechanism, it's just a pattern, and this pattern can help you to identify the product without having to go through the mechanism. This is not a mechanism you have to know, but again, you'll be asked one of these ester formations on the test, and if you can show the mechanism, then you can gain yourself the correct mechanism, you can gain yourself a bonus point. Alright, let me give you an example of this. Alright, so here's our alcohol and here's our carboxylic acid. So it's important to be able to identify those right off the bat. Also, you'll notice that they don't have to be in any particular order. You don't have to have the carboxylic acid first or the alcohol second. So what I would want you to do first is draw the carboxylic acid, that's the one with the C double bond O and the OH, and underneath it go ahead and draw the alcohol. Now draw them in such a way that the O from the alcohol is going to be near to the C double bond O. Now you'll know that the C double bond O will join to the O that's on the alcohol, and then what's going to happen is that the OH from the carboxylic acid and from the H from the alcohol will form water and will end up joining the C double bond O with the oxygen. Alright, and there's our final product with water coming off as well. This bond here that I've got in the dotted line is this one right here that I'm circling. So we're getting a new bond, and you'll notice we lost the hydrogen from the oxygen on the alcohol, and we lost the OH off the C double bond O. And that's the best way of knowing what's going on with the pattern. Now this is also emulated in the mechanism. So you can see that what actually happens in the mechanism is the H plus attacks the C double bond O, and then the O from the alcohol actually attacks the resultant C plus. So the mechanism is sort of a mirroring of what's going on with this pattern up here.